Are we alone? I mean, it's the big question, isn't it? It's something we humans have been asking for, well, forever. And today, we are getting closer than we have ever been to finding an answer. So let's dive into the incredible science behind the search for another Earth.
You know, this idea, it's not new at all. Way back in 1584, this philosopher, Giordano Bruno, he imagined this infinite universe, just jam-packed with countless other worlds, a lot like ours. But for centuries, that's all it was, right? Pure speculation, a dream. So what happened when that dream finally slammed into modern astronomy?
Well, this happens. As of right now, we have confirmed the existence of over 6,000 planets outside our own solar system. And that's not some philosophical concept. That is a hard, verified number. We've literally gone from dreaming about other worlds to cataloging them.
Okay, so what exactly are we talking about here? These thousands of new worlds. As you'd expect, scientists have a name for them.
They're called exoplanets. The definition is super simple. It's any planet that orbits a star that isn't our sun. The very first confirmed discovery was back in 1992. And ever since then, it's like the floodgates just burst open.
Now, you might be thinking, hold on a second. If these planets are light years away, how in the world do we know they're there? It's not like we can just point a telescope and snap a picture of them. The answer is actually pretty clever. We look for their shadows and their wobbles.
And this chart just lays it out perfectly. The vast majority, look at that, 75%, are found using something called the transit method. And you'll notice how tiny that little direct imaging slice is. It tells you we're mostly finding these worlds indirectly. So let's take a look at the two biggest techniques.
So the transit method is just beautiful in its simplicity. Imagine a tiny moth flying in front of a giant streetlight that's miles away. You can't actually see the moth, right? But what you do see is the light dip just for a second. That's exactly what our powerful telescopes are looking for, a tiny, rhythmic dip in a star's brightness that tells us, hey, a planet is circling around me.
The second biggest method is called radial velocity, but I like to call it the wobble method. A planet's gravity doesn't just affect other planets, it also tugs on its own star, making that massive star wobble just a tiny bit. And we can actually detect that wobble as a minuscule shift in the color of the starlight. The precision needed here is it's staggering. We're talking about measuring a star's speed changing by just a few meters per second from light years away.
Okay, finding planets is cool, no doubt. But the real excitement, the stuff that grabs all the headlines, is the search for planets that could actually host life. This is the hunt for a habitable world.
And you've seen headlines just like this one, right? This is from a real online discussion. It feels like every few months there's a new announcement, a new next Earth that gets everybody incredibly excited.
But this is where we need to be a little careful, because the public's idea of what a habitable planet is and the scientific definition, well, they can be two very different things.
So here's the crucial difference. When we hear habitable, we immediately picture Earth 2.0, with oceans and forests. But for an astronomer, habitable just means the planet is in the habitable zone. You've probably heard it called the Goldilocks zone. It's not too hot, not too cold, but it's at just the right distance from its star that if there's any water there, it could be liquid on the surface. That's it. It's a starting point, not the finish line.
And even being in this special zone is no guarantee. A lot of these planets orbit really volatile red dwarf stars that can just blast their worlds with lethal solar flares. And many others are tidally locked, which means the same side always faces the star. So you'd have one side in a perpetual scorching hot day and the other side frozen solid in an endless night. Not exactly a vacation spot.
So to get past just finding a rocky planet in the right spot, we have to go a step further. We have to start analyzing the actual atmospheres of these worlds, hunting for the chemical fingerprints that life might leave behind. Let's look at a fascinating case study that shows this in action, a planet called K2-18b. It's a super-Earth, meaning it's way more massive than our planet, and it sits right in its star's habitable zone. For a very good reason, this has become one of the most studied exoplanets out there.
So check this out. Using the incredible power of the Hubble and James Webb Space Telescopes, scientists took a look at its atmosphere. They found water vapor. Okay, cool. Methane and carbon dioxide. Also interesting. But then, they found a possible trace of something called dimethyl sulfide, or DMS. Now here on Earth, DMS is almost exclusively produced by life, specifically tiny critters in the ocean like phytoplankton.
So this is the moment, right? A gas that's pretty much a calling card for life on our planet has potentially been spotted on a world 124 light-years away. Have we done it? Have we finally found proof?
Well, not so fast. As NASA reminds us, science is all about being careful and thorough. Finding one potential biosignature is an absolutely thrilling clue, but it is not proof. Scientists have to rule out every single other non-biological way that gas could have been made, and that takes an enormous amount of work. The bar for proving alien life is, and absolutely should be, incredibly high.
So the search so far has really been about finding a planet like Earth. But some scientists are starting to ask a totally different question. What if Earth isn't the best we can do? What if there are worlds out there that are even more suited for life than our own?
And this leads to the amazing, kind of mind-bending concept of a superhabitable planet. This is a world that might be bigger, wetter, warmer, and older than Earth, providing an even better, more stable cradle for life to begin and to really flourish.
So what would a place like this look like? Well, it might orbit a star that's a bit smaller and lives longer than our Sun, which means more stability over billions of years. It could be older than Earth, giving complex life more time to evolve. And imagine a world with smaller continents and vast shallow seas that could create way more biodiversity than Earth's deep oceans and huge dry land masses.
And the best part is, we're actively designing the tools to find these places. Future missions, like the proposed Habitable Exoplanet Observatory, HabEx for short, are being designed to do what used to be pure science fiction, to directly take pictures of these Earth-like and even superhabitable worlds and scan their atmospheres for definitive signs of life like oxygen and water.
So as our catalog of known worlds grows from thousands to tens of thousands, and eventually even more, the whole search starts to change. We're moving from a question of existence to a question of location. The data is telling us that our galaxy is probably teeming with planets. And maybe, just maybe, very soon, the question will no longer be, are we alone? But rather, okay, where are our neighbors?